So in the previous lecture we have seen introduction part for the signals and systems, where we have studied about what is signal, what is system. Now we will see about classification of the signals based upon the amplitude level only. Okay, different types of the classifications are there, but in this lecture we will see the classification of the signals based upon at what instance of time what is the amplitude. Okay, based upon this criteria we will classify the signals. And first one is this particular continuous time signal. So if you see this signal, as I said previously, x of t is one signal, and I told that any information is a signal, and the signal is the function of one or more independent variables. Here we will deal with one dimensional signal only. That means within the bracket here time is there, one independent variable, so it is one dimensional signal. The signal is x of t, and for in this case I have taken x of t is a sin t, or you can take sin 100t, sin 10t, whatever it may be. About the representation of the sinusoidal signal I will tell later. So x of t is equal to sin t. So the relationship between x and t is given by this particular sin t signal. So here on x axis I have taken time, on y axis x of t is there, and that is equal to sin t. In this manner I have represented. So what is continuous time signal means these cycles will be repeating like this up to infinity. These cycles are repeating like this for the negative values of time, and for the positive values of time the cycles are repeating. Okay, so and that means this particular mathematical representation is valid from minus infinity to plus infinity. For all values of t, the x of t is nothing but sin t only. That's why we have represented here minus infinity less than t less than infinity. For all values of time, this is the representation of the signal. So if you observe here, for example, this whatever the values I am writing here, that may not be suitable for this particular signal, but for the explanation of this particular continuous time signal I am taking here. So this is 0, this is 10, and this is 20, and here 40, like that it is there. Here 30 and here 40 is there. If you see what is the value of this particular signal means you need to tell the amplitude only. Value of the signal is nothing but amplitude of the signal. But the value of the signal is depending on time. Okay, for all values of t, there is not a single amplitude is available. So at t is equal to 0, as t is changing, you see here at t is equal to 0, at this point the amplitude of the signal is also 0. So when t is 0, the amplitude of the signal is 0. That is represented like this, x of 0. Okay, this notation is very important. At t is equal to 0, what is the amplitude of the signal? The amplitude is also at 0 only. That is represented with the amplitude is 0, and that is equal to x of 0. You see here, generally the signal is represented with x of t. But we have made t is equal to 0 means wherever t is there, we need to substitute 0 only. So x of 0 is equal to sin 0. Sin 0 is 0, that already we know. So it is equal to 0. So instead of telling all these things, I will ask what is x of 0? What is the meaning of x of 0 here? That is 0. Okay, what is, how to tell this one? The value of the signal x of t at t is equal to 0. That is the meaning of x of 0. The value of the signal x of t at t is equal to 0 is nothing but this particular 0. Next, here 10 is there means here 5 is there in between these two. And here plus 1 is the amplitude, here minus 1 is the amplitude. Peak amplitude is plus 1, and here negative peak amplitude is minus 1. So next I am asking about at t is equal to 5 seconds, at t is equal to 5 seconds, what is the amplitude of the signal? So by observing this graphical representation I can tell at t is equal to 5 seconds the amplitude is given by 1. Or simply we can able to represent that is x of 5. X of 5 is equal to 1. All these things are same. Okay, at t is equal to 5 the value of the signal is 1, that is represented with the x of 5. At t is equal to 5, that's why we are substituting here x of 5. But sin 5 is not 1, so don't consider this particular mathematical representation for explanation of these amplitudes. Just in order to tell it is a sine signal I have taken here. Okay, So don't consider this one for this. It is not sin t signal. It is the time period is here 20 I have taken, so its frequency will be varied. So here I need to change. Afterwards, I will give the mathematical representation for this one perfectly. Okay. So what is to be known here in the sense, at what value of t, what is the amplitude, that we need to know. So at t is equal to 0, the amplitude is 0, that is represented with x of 0. At t is equal to 5, what is the amplitude is there, that is x of 5. At t is equal to 10 is nothing but that is represented with x of 10. At t is equal to 20, the amplitude is 0, that is represented with the x of 20. Okay. So actually we are talking about continuous time signal. You can take here t is equal to 0, t is equal to 5 and t is equal to 1.5 also you can take. T is equal to 2.9 also you can take. For all values of t you have to define. Okay. For all values of t means from minus infinity to plus infinity you need to define the signal, and in that this t can be integer, the t can be non-integer. All values of t, all values of t means the t can be integer value, integer means 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3 like that, and non-integers, that means in between 0 and 1, in between 1 and 2, for all the decimal values also, it will be defined. The amplitude of the signal should be defined for all values of t. This is a simple definition I can give for the continuous time signal. Okay, it is a signal where the amplitude is defined for all values of t. Otherwise, it is a signal where the amplitude is defined for integer values of t and for non-integer values of the t also. All values means these two only we are including. So here if you see, the amplitude is defined for t is equal to 0, the amplitude is defined for t is equal to 1, the amplitude is also defined for t is in between 0 and 1 also. Okay, in between 0 and 1 so many values are there like 0.1, 0.2, 0.3, 0.33, 0.333 like that. So many decimal values are there in between 0 and 1. Okay, that means all these are non-integer values. 1 is the integer value, 0 is the integer value. So this particular signal is defined its amplitude for integer values 0 and 1 and for non-integer values in between 0 and 1 also. So for all the integer values, for all the non-integer values, the amplitude is defined. That's why it is called continuous time signal. That is the definition of the continuous time signal. Okay, and we have to give the mathematical equation for this one. This sin t is not the mathematical equation for this one, because what is the general mathematical representation for the sinusoidal signal means you can take for example f of t is equal to a sin omega t plus phi. This is the general mathematical representation for the sinusoidal signal. Okay, where omega is the angular frequency measured in radians per second, and that is related with the normal frequency measured in hertz, that is 2 pi f. Omega is equal to 2 pi f. So this particular signal is having, actually we will have the periodic signal and non-periodic signal classification later, but because I have taken the example here sine signal, now only I am telling what is the time period of that particular signal. So periodic signal means certain pattern of the signal has to be repeated. Okay, certain pattern of the signal has to be repeated forever, then we can tell that is a periodic signal. If you see this signal, this is a pattern. You see, this is the pattern is repeating again and again. Okay, same pattern is repeated, is repeated, is repeated. This side also it is repeated. So same pattern is repeating forever for all the values of time. Okay, so we can tell that is a periodic signal. So it is a continuous time signal because its amplitude is defined for all values of t, including integers and non-integers, and the same signal is a periodic signal also because this pattern, same pattern, the pattern can be anything, the same pattern, this is the pattern here, the pattern is repeating forever. That's why it is periodic signal also. Okay, so for every periodic signal, time period is defined. Fundamental time period capital T. Okay, how to define this one means this particular pattern is available for how many seconds? This particular pattern is available from 0 to 20 seconds. So 20 minus 0 means it is available for 20 seconds. That's why its time period is 20. Okay, this particular pattern is available for 20 seconds. The minimum value we have to take. Okay, so that is a 20. So its frequency is nothing but inverse of the time period, that is 1 by 20, that is 1 by 20. Like this we will give 1 by t, that is equal to 1 by 20. And what is omega? Omega is equal to 2 pi f. So find the value of omega, that is 2 pi into f is nothing but 1 by 20, that is equal to pi by 10. So omega is equal to pi by 10 we got. Now substitute here. What is the A value? This is the peak value. Okay, that is nothing but 1. This is not peak to peak value. It is the peak value only. Okay, so A is equal to 1. So I am writing here the mathematical representation for this one. A is equal to 1. 1 into sine of omega. Omega is nothing but how much we got? Pi by 10 into t plus it starts at 0 only. Okay, the cycle is not shifted. So phi is 0. So simply we can tell sine of pi t by 10. The mathematical representation for this one is sine of pi t by 10. This is the mathematical representation for this particular signal, not the sine t. Okay, so for simplicity I have given here sine t, but this is the correct mathematical representation for this particular signal. So here angular frequency omega is equal to pi by 10. So that is from the mathematical representation. By comparing this one and this one we can tell that one. And if you know omega is equal to pi by 10, you can get frequency f. If you inverse the frequency, you will get the time period 20. Okay, so in this way we can able to define our concept. Actual thing is here continuous time signal. So continuous time signal means the signal amplitude is defined for all values of t. Simple definition. All values of t means both integers and non-integers. So for all integer values of independent variable t and for non-integer values of independent variable t also, the amplitude of the signal should be defined. That is called continuous time signal. That means in between 0 and 1, in between 1 and 2, in between 2 and 3, non-integer values are there. So at those values also amplitude has to be defined. 0 is also the defined value. This is a very, very important point. Don't think that 0 is nothing but not defined. 0 is also a defined value only. The amplitude can be 0. The amplitude can be 0. That is also defined value. Okay, remember that one. Next, this is about continuous time signal. Now we will see about the discrete time signal. Actually, this continuous time signal can be converted into the discrete time signal. For example, this is a continuous time signal. The pattern is like this, for example, and on x-axis I have taken t, on y-axis I am taking x of t. On y-axis I have taken x of t. This is a continuous time signal. And this signal we are applying to the sampler. Okay, sampler is the device which performs sampling. Sampler is the device which performs sampling based upon the sampling theorem. Okay, all those things we will see later. So it will produce the discrete signal. The discrete signal may be like this. All the samples will be available. This is just envelope. It is not the part of the signal. That is just envelope. Okay. So sorry, here I did one mistake. That is, I should not represent the independent variable of the discrete time signal with t. I should represent with the n. I should represent with n. It is a continuous time signal where the independent variable is t. It is a discrete time signal where the independent variable is also time only, but that should be represented with n, small n. Okay, and the same signal. Okay, the pattern is like this. If you take the envelope, that is looking like this signal only. Envelope means we have to take the trace of all these samples like this. That is looking like a envelope. That envelope is not the part of the discrete time signal. Okay, only these samples are the discrete time signal. Okay, so how to get these samples from the continuous time signal means by performing the sampling process. That will be done by the sampler. All those things we will see later. Okay, so simple thing is we can get the discrete time signal from the continuous time signal by performing the sampling process on the continuous time signal. Next, the independent variable in the continuous time signal is represented with small t. The independent variable in the discrete time signal is represented with small n. Both are times only. Both are measured in seconds only. And the dependent variable, in this case I have represented with x of t, you can represent with g of t, f of t, y of t, whatever it may be, but I have taken x of t. Because this discrete time signal, it came from the x of t, the dependent variable has to be represented with x of n. So we can tell that this is the signal obtained from the x of t. If it is g of n, I can tell it is a signal obtained from the g of t. So this is the thing you have to remember in the representation of the discrete time signals. Till now we did not define the discrete time signal, just a representation I am giving. So this is a continuous time signal. We perform the sampling process by the sampler. So you got the discrete time signal where the independent variable is represented with n and the dependent variable is represented with x of n because it came from the x of t. And one more important point is you should represent the continuous time signal, for example like this x of t, then the corresponding discrete time signal has to be represented with x of n. Okay, what is the observation you are making here? X of t, x is the dependent variable, t is the independent variable because it is in the bracket. Here x is the dependent variable and n is the independent variable. But one more observation you need to do, that is the independent variable for the discrete time signal should be available in the square bracket. Okay, this is the thing you should not forget. The independent variable for the continuous time signal should be in the normal bracket, that is enough. The independent variable for the continuous time signal should be available in the normal bracket. The independent variable, that is n, for the discrete time signal should be kept in the square bracket. The necessity of keeping this one in the square bracket and the necessity of keeping this t in the normal bracket you will be understood little later. Okay, for the time being you remember that one. Now we will come to the definition of the discrete time signal. So by observing this one you can able to tell simply, previously whatever the continuous time signal we have taken, how we have defined the continuous time signal, the amplitude of the continuous time signal should be defined for all values of t. All values of t means integers and non-integers. Here t is integers and non-integers. Okay, here t is involving both integers and non-integers. But while coming to this particular discrete time signal, this n on x-axis, independent variable is represented with n, where n is only integers. Where n is only integers. Okay, this is the thing you have to remember. So discrete time signal is a signal where the amplitude is defined only for integer values of n. Continuous time signal is a signal where the amplitude is defined only for, continuous time signal is a signal where the amplitude is defined for all values of independent variable t. That means for integer values of t amplitude is defined, for non-integer values of t also amplitude is defined. That's why it is continuous. That's why it is continuous. At 0 amplitude is 0 defined. At 1 amplitude is for example 1 defined. But in between 0 and 1 also some amplitudes are there. So amplitudes are defined in between 0 and 1 also. That means for non-integers also amplitude is defined. That's why it is a continuous signal. But in this case, at 0 amplitude is 0, at 1 amplitude is something is given, for example 0.2, at 2 amplitude is given as 0.5, but in between 0 and 1, but in between 1 and 2 amplitude is not 0. You should not consider in between 0 and 1 amplitude is 0. You should consider amplitude is not defined. Okay, here at n is equal to 0, amplitude is 0, like this we have to represent. That is indicating at n is equal to 0, amplitude of this particular signal is 0, but in between 0 and 1, for example, at n is equal to 0.5, at n is equal to 0.5, what is the amplitude of this particular signal means you should not tell 0. It is the wrong answer. The amplitude is not defined. This is the correct answer. This is the correct answer. Previously, I have told that 0 is also the defined value. So, if you take n is equal to 0, what is the value of the amplitude means you can tell amplitude is 0. This is correct. At n is equal to 0, amplitude is 0. This is correct. But at n is equal to 0.5, amplitude of the signal is not defined. You should tell like that. Amplitude is not equal to 0. Okay, amplitude is not different, because it is a discrete time signal where you should take n values are integers only. I should not ask like this. Okay, I should not ask like this because it is a non-integer. 0.5 is a non-integer. I should not ask the amplitude of the signal at n is equal to 0.5. The question itself is wrong. I should ask the amplitude of this particular signal only for integer values of the n only. Only for integer values of the n only, like at n is equal to -1 what is the amplitude, at n is equal to 0 what is the amplitude, at n is equal to 30 what is the amplitude, like that I can tell. And amplitude can be 0, that is also the defined value, but for the non-integer values of the n you should tell amplitude is not defined. Okay, so this is about the discrete time signal. Once again I am giving the definition for the continuous signal and the discrete time signal. Continuous time signal is a signal where the amplitude is defined for integer values of independent variable and non-integer values of the independent variable. And in case of discrete time signal, the amplitude is defined only for the integer values of the independent variable only. Okay. Now next, quantized signal in the digital signal. We have taken this particular continuous signal, for example x of t. X of t is the continuous time signal where I am taking what is the amplitude and what is the time. These two things I will classify with respect to this one. Next, I have got x of n. By performing the sampling process on the x of t, I got x of n. This is x of n. Okay, I got from the x of t by performing the sampling process. Next, this quantized signal I am representing with xq of n, and the digital signal I will represent later. So these three signals you observe. I have x of t. I have performed the sampling process. I got the x of n. I performed the quantization process. I got xq of n. Okay. So x of t. What is amplitude? Amplitude is also continuous. So amplitude can be integer and non-integer. Anything is possible. Non-integer. Time is also integer and non-integer. Time can be integer and non-integer. Amplitude is also integer and non-integer. If you have doubt, you can see here. Like this we have given. For example, it is 1, here 0, here 1, here 2 is there. At t is equal to 0, amplitude is 0. At t is equal to 1, amplitude is 1. At t is equal to 0.5, amplitude is 0.5. Amplitude is 0.5. So amplitude can also be non-integer value. In case of continuous signal, amplitude can be integer and non-integer. Time is also integer and non-integer. But in case of discrete time signal x of n, time is only integer. Time is only integer. That is the definition we have given. But amplitude can be integer and non-integer. Amplitude, we did not talk about amplitude in case of discrete time signal till now. But amplitude can also be non-integer also. If you see the previous one, here you see the amplitude here 0.5 I have given, here 0.2 I have given. That means the amplitude can be non-integer. But time should be integer only. Okay, the time should be integer only. So this is the thing you have to remember. In case of quantized signal, from the discrete time signal only we will get the quantized signal. So it is integer, time is integer. Here amplitude is also integer. Here we can tell amplitude is integer or quantized value or quantized level. Any one of the quantized level will be there. All these things will be understood afterwards. Okay. So this is a comparison table I can give. From this you can able to define the any one of these three signals. Quantized signal means amplitude is integer and time is also integer. Okay. Here integer in the sense we can take any quantized level. Next, discrete time signal means time should be integer only, but amplitude can be integer and non-integer. And this continuous signal means both amplitude and time can be anything, non-integer or integer. Okay. After getting this quantized signal, how this signal will be there? Here you see, this is the continuous signal. This is the envelope to draw the samples. That means this is the discrete time signal. For example, it is 5, it is 4.9 and it is 3.1. Like this amplitudes are there. So now I am going to draw here quantized signal. 5 will be 5 only, but 4.9 will be 5 will be 5 only, 4.9 will also be equated to 5 only, 3.1 will be equated to 3. It will be rounded off to the nearest integer value, like that we can consider. Okay, for the time being, we can able to consider that these non-integer values will be rounded off to the nearest integer values. Okay, so 5 will be 5, 4.9 will be equated to 5 only, 3.1 will be equated to 3. So this is a quantized signal represented with xq of n. Here n is there. This is a sampled signal represented with x of n. Here n is there. It is a continuous time signal. It is x of t. It is t. Okay, now you can able to understand the difference. So in the continuous time signal, continuously amplitude is changing. In the discrete time signal, the amplitude is defined for integer values of the independent variable, that is n, but amplitude can be integer and non-integer. But in case of the quantized signal, the amplitude and time both can be integers only. So here samples are there. These are called samples. These are called samples. This is a signal can be obtained by performing the sampling process on the continuous signal. So these are called samples. This here also samples are there, but amplitude is varied as compared to this one. Here samples are there. The samples or this quantized signal is given to encoder, then here you will get the binary data. Binary data is nothing but it is involving zeros and ones, that is called the digital data, digital signal, that is here. Okay, we will deal with here this particular continuous signal and the discrete signal in our subject. That is enough. Okay, so this is about what is continuous signal, what is discrete signal, what is quantized signal, and what is digital signal. Okay, and these are the assignment questions. Just definitions I am asking. You can able to draw the example signals also. That is define continuous time signal, define discrete time signal, define quantized signal, and define digital signal. Thank you.